let's do some math for fun. Today we are still going to integrate the integral of e power of ax plus b times sine of x plus d and e power of ax plus b times cosine of cx plus d, but this time we are using the complex number. And watch to the end of this video because the result is going to be really complicated. So now, as always, if you guys watch on the previous video on how I solved the previous integral using complex number, maybe we will also do the same setup because we are going to make the whole integral meet the Euler's formula. So then we let z equal to the integral of e power of ax plus d times cosine of cx plus d plus the letter I times the integral of e power of ax plus b times sine of cx plus d. And we can group these two integrals to become a simple integral, and sorry, I forgot the dx. Then z is equal to the integral of e power of ax plus b. I also factorize the e power of ax plus d times cosine of cx plus d plus I times e power of ax plus b times sine of cx plus d dx. Then we factorize the e power of ax plus b out, then e power of ax plus b times cosine of cx plus d plus I times sine of cx plus d dx. And then this whole thing is equal to the integral of e power of ax plus b times e power of cx plus d times I and then dx. Then z is equal to the integral of e power of ax plus b plus times e power of cxi plus di dx. Then z is equal to the integral of e power of ax, so ab plus di plus ax plus cxi. We can factorize the x out, then which is equal to a plus ci times x dx. And then this thing is very easy to solve, so we can just factorize it out. But in order to do that, I will just to make things more simpler. That is, now since e power of b plus di is just a constant, so I can just take it out. So which is equal to e power of b plus di times the integral of e power of a plus ci times x dx. And then solve this integral is very easy, which is equal to e power of b plus di over a plus ci times times e power of a plus ci of x. And if you guys watch on the previous video on how I solved this, how to say, now look at what we got here. Now which is, now this thing is equal to e power of b plus di and then times e power of a plus ci of x over a plus ci. If you guys watch my previous video about how to solve this the previous set of integrals using complex numbers, look at what we got here. Now this is a paper that I get from the previous video. Now look at here, 1 over a plus bi times e power of a plus bi over x, which will end to this, right? Which will end up to here. So we are just going to replace b with c. Then this whole thing is going to add up the similar thing as shown on here. So this is going to be, so z is going to be equal to e power of b plus di times e power of ax over a square plus c square times a times cosine of bx plus b times sine of times c times sine of cx, and then plus I times a times sine of b times cx plus c times cosine of cx, and then close. And what we got right here is e power of b plus di is same as e power of b times e power of di, and e power of di is equal to e, so this e power of di is going to be equal to cosine of d plus I times sine of d, and then we got to multiply this whole thing with that thing. How are we going to supposed to do? Well, that's way too complicated, right? So let me just rewrite this equation once again. So this equation, this integral, is very hard. It's not hard, but it's complicated because you got so many math to do. So z is equal to e power of ax plus b over a square plus c square times sine of not sine, times cosine of d plus I times sine of d times this whole thing. So a times cosine of cx plus b times sine, not b anymore, c times sine of c times sine of cx, and then plus I times a times sine of, sorry, this is minus, this is supposed to be minus, then a times sine of cx minus c times cosine of cx, and then close. So we have to expand this whole thing. It's insane. So I will expand the cosine to here. So I will just do, I maybe just do in a separate paper. This is too complicated to fill in this space, because in the end I'm going to just do the final equation just like right here. So we compare the real part and the imaginary part of z. Now let's try to expand this whole insanity. Now cosine times, now we're going to cosine of d times this term. So cosine of d times a times cosine of cx plus c times sine of cx, and then close bracket, plus I times cosine of d times a times sine of cx minus minus c times cosine of cx plus I times sine of d times a times cosine of cx plus c times sine of cx and then finally minus, because I times I, so it become negative 1 times sine of d times a times sine of cx minus c times cosine of cx. And then we are going to expand this whole thing. This is insane. I don't know if I can hold up on my math brain right now. So we are going to expand this because I already expand this term and expand this term and then expand. Then we are going to expand this one. So which is equal to a times cosine of d times cosine of cx plus c times sine c times cosine of d times sine of cx. This is the first one. Plus I times cosine of d times I times, so ai cosine of d times a times so this whole thing, so ai times cosine of d times sine of cx minus ci minus ci times cosine, so ci times cosine of d times cosine of cx. And so yeah, so it's going to take more time. So I times cosine of d, let me just double check the answer. So a times sine cosine of d times c times sine cosine of d. Okay, so far no problem at all. Plus ai times sine of d times cosine of cx plus ci times sine of d times sine of cx, and then finally minus a times sine of d times sine of cx plus sine c times sine of d plus c times sine of d times cosine of cx. Okay, so we are done expanding, and then let's check if there is some similar terms, some similar pattern that I can recognize. Now a times cosine, now look at here what I found. A times cosine of d times cosine of cx minus a times sine of d times sine of cx. That's same as a times cosine of cx plus d, because remember the trigonometric sum and difference formula. So we are done expanding this one, so I will just take, and then c times cosine and sine, and c times sine and cosine, that's the sine, that's equal to c times sine of cx plus d. So we are also done this one. And then we got the expression. So we got some terms that fills with the complex number I. So I will separate these two. And then now a times cosine of d times sine of cx plus, is there any plus, plus sine of d times cosine of cx, that is equal to a times sine of cx plus d. So we have done this one. And then finally c minus, because so c times sine of sine minus, so ci times sine, then minus c times cosine. Now because now these two terms now plus, because they have positive, ci times sine of d times sine of cx minus ci times cosine and cosine cx, we can factorize ci, and then we can factorize negative in order to make it equal to cosine of d times cosine of cx minus sine of d times sine of cx. That's same as cosine of cx plus d. So c times cosine of cx plus d. Now remember these two formula. When you have sine of they have sine of a plus b which is equal to sine of, in fact I will just write plus minus, sine of a times cosine of b plus minus cosine of a times sine of b, and cosine of a plus minus b is equal to cosine of a times cosine of b minus plus sine of a times sine of b. Now, if you don't understand what am I doing right here, you can just do it by yourself. Now, so basically now a times cosine of d plus cosine of cx minus a times sine of d times sine of cx. Now, this we can group together, become a times cosine of cx plus d if after we factorize the a out, and then c times cosine times sine of cx plus c times sine of d of cosine of cx. That's same, if you factorize the c, that's same as cosine of d plus times sine of cx plus sine of d times cosine cx. That's same as sine of cx plus d times c. And then the rest of the term that fill is I, we factorize out. And then what we can see here is the remaining term for this one. If after factorize I, the remaining term is a times cosine of d times sine of cx plus ai times sine of d times cosine of cx. So after we factorize a, I will get cosine of d times sine of cx plus sine of d times cosine of cx. That's going to be equal to sine of cx plus d. And then the remaining term right here is ci. Now after we factorize I, then the remaining term here is c times sine of d times sine of d cx minus ci, this minus ci times cosine of d times cosine of cx. If you factorize the c out, I will have sine of d times sine of d times sine of cx minus cosine of d times cosine of cx. But we cannot do like that because in order to apply this, we have to make sure cosine first, then sine times sine. But this one is sine times sine minus cosine times cosine. So in order to simplify, become cosine of A plus B, we have to take out the negative. Then that will exchange the term. Then we become cosine of D times cosine of CX minus sine of D times sine of CX. And then we can simplify together as like become cosine of CX plus D. And if you still don't understand, you can just try to expand this whole thing, and then you can try to simplify and see for yourself. Now, the final process. We have already done this whole insane expression. Now let's do this one. Now, we already expand this, so this one is equal to this, which is equal to this, which is finally equal to this one. So z is equal to e power of ax plus b over a squared plus c squared times a times cosine of cx plus d plus b times sine of cx plus d and plus I times A times sine of cx plus d minus c times cosine of cx plus d. Close bracket, and close bracket. Now, if after we expand each of these, we will get the similar form as the initial one right here, and then we can compare the real part and imaginary part, and we are done. I'm very tired by expand this whole expression. I didn't even prepare the script. I am just going to expand it using my math brain, so crazy math right here. So the real part of z is equal to the integral of e power of ax plus b times cosine of cx plus d dx, which is equal to e power of ax is equal to e power of ax plus b over a squared plus c squared times a times cosine of cx plus d plus b plus c times sine plus c times sine of cx plus d, and the imaginary part of z is equal to the integral of e power of ax plus b times cosine sine of cx plus d dx, which is equal to e power of ax plus b over a squared plus c squared times a times sine of cx plus d minus b times cosine of not b anymore, c times cosine of cx plus d, and we are done. This is the most complicated integral that use the complex number to solve in order to solve some integrals. I am very tired from this, especially expanding this crazy math expression, and in order to do that, you have to apply these two equations, the trigonometric sum and difference formulae, in order to simplify this crazy expression into this into until this simple, and then substitute it here, and then we're just going to expand and then compare the real part and imaginary part in order to solve these two integrals. So we got these two shortcuts for these two integrals, and we are officially done. I'm tired. And as always, if you guys want to see more, if you guys really enjoy if you guys really enjoy this video, especially watching me torturing on this, expanding this crazy math expression, leave a like and subscribe to subscribe to the channel to see more upcoming math videos like this, and subscribe to my channel for more upcoming math videos, and I will see you guys next time.